Hello, it's RProg here, and welcome to another C++ tutorial. A few things to point out real quick. I'm using Visual Studio instead of Notepad++, I believe, and command line. And the reason why is so to simplify the process for me, as we're going to get more into more complicated subjects later on. And secondly, I'd like to apologize for taking so long to basically to make this video, because life got in the way, and I believe it's been 3 years since my last video, and that's entirely too long. So with that out of the way, I wanted to talk about pointers in this video. So a pointer is a special variable type known as a reference type that doesn't store any data. In fact, it only stores memory addresses. So any variable that you declare, the variable, objects, whatever, that you use within your entire program, is going to be stored in a memory address. So for example, I'm going to declare an integer. I'm going to name it A, and I'm going to assign it 10. And with that, I'm going to output its value. Learn to type you. And then I'm going to I'm going to output its address. So how do you output its address? By using the address of operator. That is the ampersand. So we use the address of operator, the variable name that we want the address of, and that should do it. So let's build and run this and see what she looks like. And as you can see, we are outputting 10, which is what we assigned it, and we're also outputting its memory address, which is what we declared here. We want its memory address. Okie dokie. So how about those pointers that we were talking about? What do they look like? Very simple. They look like the data type. They can be any data type for that matter, with the asterisk key, the asterisk symbol. So a pointer can be of any data type whatsoever. In this case, we'll make it an integer pointer just to simplify it, and we'll call it pointer A. And we need to assign it a memory address. Now, right off the bat, I'm going to point out that whether the asterisk is here or here does not matter, because it's the same thing. So you can keep your comments about where to put those asterisks. It does not matter. So how do we assign a memory address to a pointer? By using, once again, the address of operator. So we're going to use the assignment operator here to assign it. Use the address of, and then we're going to use A in this case, and that's it. You have now assigned an address to a pointer. And once again, this can be of any data type whatsoever, period. Pointers can exist of any type. So what can we do now? We can output its address first and foremost. So you would think it should be the same as A, correct? Since you assigned it the address of A. Okay, you are correct. So let's see what this looks like. Should see something interesting here. That ain't right, is it? Well, remember a while ago I said it was a special data type. A pointer is a reference type, which means you do not need to use the address of operator on a pointer. The compiler already knows it's a pointer. It only stores a memory address, so you don't need to use the address of operator. So as you can see, if you just declare it plainly, voila, we now have the address of A. Even a pointer itself is stored in a memory address, so keep that in mind. That's what you're outputting, or we were outputting, so I should say, when we use the address of operator in front of the pointer, we're getting the address of the pointer. Makes sense, correct? But that's not what we want. We want whatever the pointer is holding, which is, of course, a memory address. And that's going to be the memory address of A. So what else can we do? We can also we can also access the value that's contained within that memory address. Once again, a pointer is a reference type. So how do we get that value? By using the dereference operator. The dereference operator, big shocker here, is also the asterisk key. You would put that in front of the pointer variable name. And we'll go ahead and give this a build. And there we are. Getting its address, which should be the same as A, as well as its value. So that pretty well proves that pointer A is indeed pointing to A, right? We should be able to do other things, and you would be correct. If you assumed that is. What we can do is we can also change that value within A using the pointer, because since this controls A's memory address, it essentially controls A. So once you control an object's memory address, you can completely control that object, period. And how do you change the value of A using the pointer? By dereferencing the pointer and changing its value. For example, we're going to dereference pointer A and assign it another integer. In this case, we'll use 22. And then we're going to output not the value of PA like we did here, or pointer A. We're going to output A instead, just to show that it did indeed change the value of this variable. So let's build and run it. Come on, drag you. There you go. And here you are. We are getting the variable A is 22, changed by the pointer. So that shows that you can completely control an object using a pointer. But there is a rule of thumb. There are actually many rules of thumb in dealing with raw pointers, and I say raw pointer because there's also things known as smart pointers. We'll tackle that later on, but not in this video. But there's one rule of thumb that I'm going to point out, and it deals with something known as the address of 0. What is the address of 0? It's commonly called a null pointer. So what is a null pointer? Besides, a pointer being assigned to null. What does it look like? We're just going to call this int p, make that a pointer. And the address of 0, for example, could look like this. Since they store a memory address, assign it the address of 0, very plainly. Or you can also assign it null. Null means the same thing. As you can see, it shows it here. Null is defined as 0. Or you can also use the more modern way, which is null pointer. There we are. It all means the same thing, whether it's 0, null, or null pointer. It all means the address of 0. So, what does this have to do with the rule of thumb with raw pointers? You must not dereference a null pointer. The reason why is because the address of 0 is a special place in memory that stores nothing. It cannot store anything whatsoever. It is blank. It is nothing. The very definition of nothing. So I'm going to show you exactly what happens when you try to dereference a pointer that points to the address of 0. As soon as I learn how to type. So we're going to go ahead and build this. We should get a crash. Gave us a read access violation. That P is a null pointer. Go ahead and stop that. Close the execution. That's what the execution looks like. And of course, as stated, the execution flips out because there's nothing in the address of 0. There's nothing there. so it doesn't know what to do. It's the equivalent of division by zero. It makes no sense to try to grab a value from the address of zero because nothing's there. And I know it sounds like I sound like a broken record by saying this, but it's that important, guys and gals. Do not dereference a null pointer. It makes no sense to do so, and it can be done accidentally. And later on in future tutorials, I'm going to show you how to protect against dereferencing a null pointer. So with that, that pretty well covers the basics of a pointer. In later videos, I'll go more in depth to pointers, but as of right now, I'm not going to really announce what my next video will be about. So if you like the video, please like, share, and subscribe. And I'm not perfect, guys, so if I made any mistakes, please let me know in the comments below. And with that in mind, happy coding. Thank you for watching.